You check the time on your phone without thinking about it. A number ticking upward, exactly the same for you as it is for everyone else on the planet. It feels like the most solid thing in your life. But the real answer is far stranger than a number on a screen, because physicists have proven again and again that the time you are trusting right now is not fixed at all. For most of history, people assumed the universe ran on a single unbroken clock. According to the current model, the universe began about 13.8 billion years ago in a single burst that created space and time together. Since that moment, the thinking went, the whole universe has been ticking forward at one steady shared pace. Nothing could speed it up, nothing could slow it down. Then about 100 years ago, Albert Einstein said that was wrong. Time, he argued, is not fixed at all. It can stretch, it can compress. Move fast enough and your personal clock runs slower than everyone else's. Almost no one believed him at first. It sounded like a theory with no way to prove it, but over the following decades, one experiment after another confirmed that Einstein was exactly right. Here is the strange idea underneath all of it. The speed of light never changes, no matter who is measuring it or how fast they are moving. Picture two beams of light shooting off in opposite directions from the same point. Logically, each one should be racing away from the other at twice the speed of light. Measure it though, and that is not what happens. Each beam still clocks the other at exactly one light speed, never faster. And measured on its own, each one is still traveling at exactly light speed too. Not doubled, not halved, just light speed every single time, no matter which direction you look. You can see the same effect looking up at the night sky. Some of those stars are racing toward Earth. Others are racing away at speeds that would make a rocket look motionless. If light behaved the way you would expect, starlight from an approaching star should hit your detector faster than light from a star holding still. It never does. Every star's light arrives measuring the exact same speed. Light does not care how fast its source was moving when it left. It just goes. Now put yourself in the picture. Earth is not sitting still. It is orbiting the sun at about 30 kilometers every second. Light reaching you from straight ahead and light catching up to you from behind should measure differently, shouldn't they? They do not. However you move, light keeps exactly the same distance from you at exactly the same speed, as if it somehow already knows where you're going to be. It is one of the most unsettling facts you will ever learn, and physicists still cannot fully explain the mechanism behind it. They can only tell you it is true and that it holds up in every experiment ever run. If the speed of light can never change, something else has to bend to make the math work. That something is time. Picture light traveling a longer path but still needing to arrive at the same fixed speed. The only way that is possible is if the clock measuring that trip runs slower, which means the faster something moves, the more its time stretches out. Not a little, measurably. Move close to the speed of light and one of your seconds might stretch into what looks from the outside like 2. Here's the part that should really unsettle you. You would never notice it happening. Move at nearly the speed of light for 100 years, and to you, it would still feel like one ordinary second following another, completely normal. It is only to someone watching from a distance that you would look like you are moving in slow motion, stretched out, drawn thin across time. You would be living an entire lifetime in what looks to them like the blink of an eye. And they would look exactly the same way to you. Everyone experiences their own time as perfectly normal. It is only from the outside that anything looks unusual at all. This is not a thought experiment. In 1971, physicists Joseph Haffel and Richard Keating tested it directly. They loaded ultra-precise atomic clocks onto commercial airliners and flew them around the entire planet, then compared them to identical clocks left sitting on the ground. When the planes landed, the airborne clocks were measurably behind, only a few hundred billionths of a second, far too small for a human to feel. But atomic clocks caught it, and the gap matched Einstein's predictions almost exactly. From there, the theory extends even further. Speed is not the only thing bending time. Mass does it too. The heavier and denser an object is, the more it warps the space around it, and the slower time runs near it. Stand beside the sun, and your clock ticks slower than someone standing on Earth. Stand beside Jupiter, slower still. Stand near a black hole and time can crawl to nearly a standstill, while everything around you still feels completely, perfectly ordinary. Meanwhile, someone watching you from a safe distance would see your entire life unfold in what looks to them like a single afternoon. It is the same idea behind the old saying about a day in heaven equaling 10 years on earth, except this time, it is not a metaphor, it is measurable physics. Push that logic to its limit and you get an idea that should stop you in your tracks. If mass slows time and the densest point in the universe carries the most mass of all, then somewhere near the center of the cosmos, time might barely be moving. From where you are sitting, the universe is 13.8 billion years old. But if there is a supermassive black hole anchoring the center of everything, it is possible that, from its perspective, barely a single second has passed since the Big Bang. Out here at the edge in the low-mass, fast-moving suburbs of the universe, billions of years have already gone by. Closer to the center, the universe might have barely begun, which raises an odd question. If low-mass places experience time the fastest, and fast time means faster evolution, faster development, faster everything, where would you actually expect to find advanced life? Not orbiting some enormous massive star where a single second stretches out for what would feel to us like centuries. Life there might still be crawling out of the water. The better bet is somewhere small, somewhere light, maybe even somewhere unimaginably small. Down at the scale physicists call the quantum world, the place too tiny to seem like it could hold anything at all. It also means the opposite is almost certainly true. Around the largest, heaviest stars in the galaxy, conditions might look perfect for life. Plenty of warmth, plenty of energy, plenty of time to work with. But if that star is massive enough, its local time could be crawling so slowly that evolution barely gets started. What looks to us like billions of years passing on a planet near a giant star might, from that planet's own perspective, still be early days, maybe nothing more advanced than fish or reptiles. Even the sun you grew up under is, by galactic standards, a comparatively small, lightweight star. That might be exactly why life had room to happen here at all. That is the physicist's answer. Time is real, objective, measurable, and wildly uneven across the universe. Philosophers tell a completely different story. To a philosopher, time is not a feature of the universe at all. It is a feature of you, a convenient invention your mind uses to organize change, what hour you wake up, how long a meeting runs, why a day gets divided into 24 identical pieces. None of that was discovered out in nature. It was decided by people for convenience. Strip away every living thing capable of noticing time pass, and under this view, time itself disappears along with them. No observer, no time, just existence with nothing there to count it. Physicists do not let that go easily. Nearly every equation describing the universe has time built directly into it. Take time away and distance goes with it, and a universe with no distance and no time collapses down into a single point. No planets, no space to hold them, nothing left to even ask the question. But a strange middle ground has emerged out of quantum physics. Some quantum physicists argue that time might behave the same way particles do at the smallest scales, sitting in an undefined, uncertain state until something observes it. Under that idea, the universe had no fixed timeline at all until the first act of observation ever happened. The moment something, anything, a person, a single cell, something else entirely, nobody knows, first perceived the universe, only then did space and time snap into place as something fixed and measurable, which means, in a very real sense, awareness itself might be what time actually is. You are not just moving through time, you might, in some sense, be made of it, and if that is true, only one moment is ever fully guaranteed to exist. This one, right now. Philosophers call this idea presentism, the argument that the past and the future were never truly real at all. Think about what actually proves yesterday happened. Only one thing, memory. And memory is notoriously unreliable. It gets distorted, it gets invented, it fades entirely, sometimes without you noticing. Even physical proof, a diploma in a drawer, a fossil pulled out of the ground, only proves something exists right now in front of you. None of it can prove where it has actually been for the last million years. It only proves it is here today. The philosopher Bertrand Russell made this exact argument nearly a century ago. He pointed out that the universe could have sprung into existence 5 minutes ago, complete with your memories, your relationships, your diplomas, every fossil in every museum, all fully intact, and you would have no possible way to tell the difference. It would not change a single thing about how you live today. Russell was a mathematician and logician by training, not a novelist. And he was so persuasive, making arguments exactly like this one, that he won the Nobel Prize in Literature in 1950. So does time move the same way for everyone around you? In one narrow sense, yes, the rate barely differs between two people standing on the same planet, breathing the same air. But in every other sense, no one's time is remotely equal. What actually differs is not the speed, it is the amount. Some lives stretch across 90 years. Others end at 20, no matter how much they managed to accomplish before the clock ran out. No equation about light, no argument about memory or observation changes that outcome. Even ancient stories about immortals and gods living for 1,000 years usually miss this point. Stretch a lifespan out that far in someone else's telling, and from the inside, it probably still feels like an ordinary 80 or 90 years. The same handful of decades everyone gets, just described by someone standing far enough away to call it forever. Length was never really the mystery. What you do inside the length you are given always was. You will probably check the time on your phone again in a few minutes, and the same way you always do, a number ticking upward, feeling as fixed and certain as anything in your life. Except now you know better. It bends around speed, it bends around mass. Some philosophers doubt it even exists outside your own mind. But there is one version of time that never bends, no matter how the physics or the philosophy shakes out. It is the one quietly running out behind everything you do today.